All right, good morning. Bright and early again. Can I answer any homework problems for you? Yes.
Number
7, 3.1, correct? Yeah, number 7. Okay, an equation of the line tangent to the graph of f at the point 2, 7 is that. Okay, find f of 2 and f prime of 2. Okay. So number 7, they say an equation of the line tangent to the graph at the point 2, 7 is y is equal to 4x minus 1. Okay. Then they say, what is f of 2? And what is f prime at 2? Okay, so the easy one is f prime of 2. Because they tell you at 2, 7. So like if we have what we know is at this point, I don't know what the curve looks like, but I know what the tangent line looks like, right? The tangent line is 4x minus 1. So let's see, that would be like 1, 2, 3, 4. So that's the tangent line to the curve at that point. So if this is the tangent line, then this is the line that gives me the slope, correct? So I just have to say, well, what's the slope of that line? Well, the slope of that line is 4, because this is y equals mx plus b, where this is the slope. So I can right now say that I know that the slope is 4. Does that make sense? Okay, and then the question is, all right, but what is the functional value of 2? Well, the functional value of 2 is just given to me by, that is the point that we're at, is 2, 7. So if f is 2, I'm sorry, if x is 2, then y must be 7. So we really don't know anything about this function right now other than these two things, but these two things give me the two pieces of data I'm looking for. Yes, sir.
37.
37. All right. Okay, so number 37 says we have f of x is equal to 1 over square root x and a equals 1/4. Okay. The question is, for the following functions and values of a, find f prime of a, and then determine an equation for the tangent line to the graph of f at the point a, f of a. Okay, sounds good. So the first thing we need to do is find the derivative at a, right? And to do that, in this section at least, we're going to use a difference quotient. Okay, so what we want to do is say, okay, then what is f prime of a? It's the limit h goes to 0 of what? F of a plus h minus f of a over h, correct? Okay, so we know what a is. It's 1/4. So we could write that f prime of 1/4 is the limit as h goes to 0 of f of 1/4 plus h minus f of 1/4 over h. But now I could say, well, what do I mean f of something? f of something is 1 over the square root of that thing, correct? So I could write that this is f prime of 1/4 is equal to, the limit is h goes to 0, of f of 1/4 plus h, but that's 1 over square root of 1/4 plus h, minus f of 1/4, which is minus 1 over the square root of 1/4, divided by h. All right. So now the question is, where do we go from here, right? So we've got to this point. What can we do to make this not quite so ugly, correct? And I think that the big problem here is that we have the square roots on the bottom. And how could we get rid of the square roots? Move them to the top. Well, okay, so you're saying we could like rationalize the denominator, so to speak, and get these square roots on top. That is true. That is one way that we could do it. The other way that I could think of that we could do it is we could also multiply the top and bottom by the conjugate of the top. And I believe that that would get rid of the square roots on the bottom. It may be a nice way. Let's go ahead and try it and see what happens. So what I'm going to do is I'm going to multiply the top and the bottom by 1 over the square root of 1/4 plus h plus 1 over the square root of 1/4 divided by the same thing, 1 over square root 1/4 plus h plus 1 over square root of 1/4. I suppose I don't have to keep on writing 1 over the square root of 1/4, because what's the square root of 1/4? What is square root 1/4? So what can you square and get a fourth? Maybe a half. Right, 1/2 squared is a fourth, so square root of 1/4 is half. So this is really just 1 over a half, where this thing is just 2, right? So that makes life a little easier, but I'm not going to do it yet because I actually think that, well, it actually doesn't matter, but let's keep going. So if I were to multiply this out, this one times this one, the ones on top are just 1. The square root times the square root just gives me 1 over 1/4 plus h. Okay, then I get this one times this one, positive, and I get this one times this one, negative. They cancel each other out, and so I'm just left with negative this one times positive this one, which is 1 over, this is negative 1 over 1/4. And then I still have the bottom, right? And on bottom, I still have that h sitting out there. And then I have this thing, which is 1 over the square root of 1/4 plus h plus 1 over the square root of 1/4. But I already said that the square root of 1/4 is 1/2, and 1 over 1/2 is the same as 2. So I might as well just write that as a 2. All right. Now the question is, has anything gotten any better? I didn't write the limit, did I? Limit is h goes to 0. Okay, so right now nothing has really gotten any better, but I think that this is a little better than it was before in that I don't have the square roots on the top anymore. So now I should be able to like combine these two fractions into one nice fraction. This, of course, is 4, right? And so what I could do is I could say this is equal to the limit, h goes to 0, of, all right, so how do I want to write this? Let's go, this is 1 over 1/4 plus h minus 4, correct? And on the bottom, we just have h times 1 over the square root of 1/4 plus h plus 2. Now, we could combine these into one fraction. Let's do it. I'm going to move over here. So the common denominator in this case would be this 1/4 plus h. So I get 1, this is equal to the limit, h is still going to 0. On top I get 1 plus 4, oh, I'm sorry, it's minus 4 times 1/4 plus h over 1/4 plus h. So I just multiplied the top and bottom of the 4 by a 1/4 plus h, and then combined the two fractions. Then on the bottom, that's the top, right? The bottom is still this h times 1 over the square root of 1/4 plus h plus 2. Okay. If I multiply through by this 4, does anything nice happen? Let's see. So this is equal to the limit. H goes to 0. Okay. If I multiply through by 4, I get 1 minus 1, right? Which is nice. And then I also get minus 4h. So the top just becomes negative 4h. Agreed? So we get negative 4h divided by, the bottom's still the same, 1/4 plus h divided by h. Let's see, how do I want to do this? Do I want to combine those into one fraction? Not necessarily. I don't think I need to. Okay, so here's the thing. This, I could think of this as a fraction in itself, and I could put it all over 1. Right? If I did, then if I flip and multiply this fraction by this fraction, it's the same thing, right? So I have something over 1, that's a fraction divided by a fraction, so I'll flip it and multiply it. So I can just put this next to this one as times, it's a fun one. Times 1 over, you have h times 1 over the square root of 1/4 plus h plus 2. Okay, and now everything's fine. The wonderful thing happens now, and the h's cancel. And h was the problem, is we couldn't plug in for 0 for h because there was an h on the bottom, and now the h's cancel. And so now that the h's have canceled, what do we have left over? Let me rewrite. This is the limit, as h goes to 0, of, on top now, all I have is a negative 4. On the bottom, things are kind of ugly, but I don't really care, because I'm about to plug in that h is equal to 0, right? So on the bottom, I just have to keep track of what I've got. I have a 1/4 plus h, and I also have a 1 over the square root of 1/4 plus h plus 2. And now if I plug in h equals 0, no bad things happen. There's no division by 0 anymore. So this h is going to become a 0. This h is going to become a 0, which will leave me with a -4 on top. And on the bottom, we get a 1/4 times. When this goes to 0, the square root of 1/4 is a half. So I get 1 divided by a half, which is 2 plus 2. So I have 1/4 times 4. So the bottom here is just 1. And I get -4. Okay, what was the problem that I started with? Let's see, 37. Oh yeah, so let me think about that for just a second. Sorry. Thanks. I'm just checking my work in my head real quick. And the point was 4. Let me look at it one more time. Oh, A is 1/4, not 4. Okay. Whew. Okay. Scared myself. I was like, oh, I did it wrong. No, that's right. It's good. Okay. Any questions on that one? Just wanted to make sure that that was a longer one. I wanted to make sure I came out with the right answer. Questions? Yes.
And one of these steps while you were doing that problem?
Yes.
I tried to find which step it was.
Was there one other? You can find it. I'll come right back.
I think I found it.
Okay.
It's like, how did you change a 1 divided by 1/4 plus h minus 4 into 1 minus 4 1/4 plus h divided by 1/4 plus h?
Okay, so which step are we talking about here? From
It was mainly on the numerator.
here to like here? Or
I believe it was like, I think you erased it.
oh, it was like at the very beginning.
Here at the very beginning.
Okay. So say it again. What were you?
It was mainly on the numerator.
What did I have?
Before you had like 1 over 1/4 plus h minus 4. No, the minus 4 is like right next to the fraction.
Oh, over here, -4.
Yeah. But then you somehow turn that into like.
Oh, yep. Okay. So what I did is I 4 is the same thing, right, as 4 times 1/4 plus h over 1/4 plus h. Agreed. So I could multiply the top and bottom of the 4 by 1/4 plus h. Agreed. So this is just 1. And so then what I did is I multiplied this through, this has the same common denominator now. And so I could write it as 1 fraction. So on top, I get the 1 from this guy, and then I get minus 4 times 1/4 plus h. So minus 4 times 1/4 plus h. I don't know if I did that all in one step or not. But then on the bottom, I have the 1/4 plus h because I have a common denominator. I think that that's what you're asking, right?
Yeah.
Does that make sense now or not as much?
I think it makes sense.
Okay. Other questions? Yeah. Oh, yeah, sure. So let's see, this was 37 or something? 37. The second part is determine an equation of the line tangent to the graph of f at the point a, f of a, the given value of a. Okay, so we're at a is 1/4. So a is 1/4. So f of a is what? So to get an equation of a line, you either need 2 points on the line, which we do not have, or you need a point on the line and the slope of the line, correct? That now we do have. So we need the point that's on the line that we know. And the point that we know, well, we have to kind of figure it out. What is the function in this case?
1 over the square root of x.
Yeah, 1 over the square root of x. So f of a, so to speak, is 1 over the square root of a. And f of 1/4 is equal to 1 over the square root of 1/4, which is 1 over 1/2, which is 2. So that gives us a point, right? So the point that we know that's on this line is the point 1/4, 2. And then the slope, or sometimes we call that m, right? The slope of that line is what we worked so hard to figure out, -4. So now we need to use a point slope equation for a line. Sometimes people are like, I don't know why. In high school, people learn different ways to find the equation of a line. And sometimes people really are like, I'm in love with point intercept, right? Mx plus b. And that is how you want to write it, okay? That is how you want to write your final answer is y equals mx plus b. But I don't know that that's always the most efficient way to find it. Usually the point intercept form is much better. And what I mean by that is, remember this guy from, you definitely saw it, but you may not have learned to use it to find your equations of the line. And that's y minus y0 equals m times x minus x0. That guy's your best friend in this situation, because what it's saying is the equation of the line is if you know the slope and you know a point x0, y0 that's on that line, then you can find the equation of the line. So we got, this is my x0, y0. So I have y minus y0, which in this case is 2, is equal to m, my slope, -4, times x minus x0, which in this case is 1/4. And now we just want to put that into the form y equals mx plus b, the standard form of a line. So we get y minus 2 is equal to -4x plus 1. Then I could add 2 to both sides. And I get that y is equal to -4x. Add 2 to both sides, and I get +3. So that would be the equation of the tangent line. But this is your best friend right here when it comes to finding equations of tangent lines, because in calculus, you almost always are going to have a point and the slope to find the equation of a tangent line. You're not as likely to know what the y-intercept is. Okay, there are ways to kind of like finagle yourself around that, but it's harder. This is the easy way. Other questions? Did I answer everything on this one that people need to see? Okay, what else can I do?
I just have a question on 51.
51, okay.
Yeah.
Yes.
When it says b prime, we're taking derivative. So first the position. No, I apologize. I didn't read the first thing. I apologize. Sorry. Physics was on my mind. So I was looking because derivative. Anyway.
You're good?
Yes.
Okay. That was easy. Let's see, somebody said something online. They said 41. Let's look at 41. Okay, so we've got f of x equals 1 over x plus 5, where a is 5. So our function is f of x equals 1 over x plus 5. And they say a is 5. Okay, yep, very good. So we want to go through the same process. We want to find what is the derivative of this function at 5. And then we want to use that information to find the equation of the tangent line. So first of all, we need to use our nice little formula for the derivative, that f prime at a is equal to f of a of limit. By the way, you should always write the limit. It's a very bad habit to not write limit in on every step. And I kind of get it. People are like, I know what I mean, but it actually can cause problems later and even now, honestly. It's important to remember, what am I doing here? Oh, I'm simplifying something so I can take its limit, right? So if you forget to write limit, or if you just get into the habit of like, I just don't write limits on my problems, I just like think I understand what's happening, it's easy to make mistakes. So just be careful. Okay, so its limit as h goes to 0 of f of a plus h minus f of a over h. Okay, that's equal to the limit as h goes to 0 of, okay, a in this case is 5. So if I say f prime of 5, this is going to be limit as h goes to 0 of f of 5 plus h minus f of 5 over h. Now I can say, well, what does it mean f of something? F of something is 1 over that something plus 5. So I could rewrite, this is the limit as h goes to 0 of f of 5 plus h. Well, that's 1 over 5 plus h plus 5. And f of 5 is minus 1 over 5 plus 5, all over h. Okay. We could simplify this a little bit just to make it a little cleaner. So I'll move up here. This is equal to the limit as h goes to 0 of 1 over 10 plus h, 1 over 10 plus h, minus 1 over 10 divided by h. All right. Now, we could do a couple different things here. We could combine these things into one fraction, and I think that that's the best way to go. So we need a common denominator for these two, which if in doubt, you can always just multiply them together, right, to get the common denominator. So that's what I'm going to do. Just going to multiply them together, and I'll get the limit as h goes to 0. So I want the denominator here to be 10 plus h times 10. So that means I have to multiply the top and bottom of this fraction by 10. So this is going to become 10 over 10 plus h times 10. And the other one, I'll have to multiply the top and the bottom by 10 plus h. So on top here, I get 10 plus h over 10 plus h times 10, all over h. Okay? Now I can combine the fractions. I get the limit as h goes to 0 of, so on top I have 10 minus 10 minus h when I distribute that negative, divided by 10 plus h times 10, all over h. And remember, if you like, h is h divided by 1. So I do have a fraction divided by a fraction here. On top, you see I have 10 minus 10. Those are going to go. So I'm just going to be left with a minus h on the top. All right, so move up here again. I get this is equal to the limit. H goes to 0. On top, I have a minus h. On bottom, I have 10 plus h times 10 times, now I'm going to take this and flip and multiply, and it will become 1 on top, h on the bottom. So I multiply by 1 over h. And now the wonderful thing happens. The whole point of this is I've got to get rid of the h on the bottom, right? That's the thing that's causing the problem from the very beginning, is I can't just plug in h as 0 because I get division by 0. But now there's an h on top and h on bottom. They cancel. And now I have the limit is h goes to 0 of, on top I have negative 1. On bottom I have 10 plus h times 10. And now there's absolutely no problem with h being 0. So now I can plug in the 0 for h. That h becomes a 0, and I'm left with negative 1 over 10 times 10, or negative 1 over 100. And so what is this? Going all the way back here, this is f prime of 5. Right, so this is the slope of the curve when x is 5. So this is f prime of 5, the slope. All right, so now I know the slope, which was part A, right, is find the slope at 5. Now I need to find the equation of the tangent line at 5, and so I need 2 pieces of information. I need a point at 5, and I need a slope at 5. I've got the slope, so my slope m is negative 1 over 100. My point, I need, what is f of 5? Yes. Question?
1/10.
Oh, f of 5 is 1/10? Yeah, what's the original function? It's 1 over x plus 5, so this would be 1 over 5 plus 5. Yeah, so 1/10. In other words, my point that I'm looking for is the point 5 1/10. And now we have our nice equation again, right? Our point slope equation of a line. We have y minus y0 equals m times x minus x0. Now I just plug in what I know. I get y minus y0, which is 1/10, is equal to m, which is -1/100, times x minus x0, which is 5. And now we just need to get it into standard form. So let's just solve for y. So we get y minus 1/10 is equal to -1/100 x, and then it would be plus 1 over what? 20? And now I just need to add 1/10 to both sides of the equation, and I get y is equal to -1/100 x. What's a 20th plus a 10th? I suppose a 10th is 2/20ths. So
0.15.
What's that?
0.15, 15 tenths.
Yeah, so I've got 2/20ths here plus a 20th, so 3/20ths. So this would be plus 3/20. And that's it. Questions on this one? Yeah, so all of these have kind of a similar strategy in some sense, and that is at the beginning, there's always going to be the h on the bottom, right? And you've got to do some algebraic work to get a h on the top so that they can cancel and you can actually get a slope answer out. And you always should be able to do it with these problems. So the tricky part of these problems is like, well, what's the algebraic thing I need to do to get there? And so you just have to think about, can I combine things? Can I multiply by a conjugate? Yes, sir.
So when you were finding out of 5 there,
Yes.
I'm a little confused on how you got to there to the equation right below.
From here to here?
Yeah.
Yeah. So obviously the h stays the same, right? So the question is, how do I get from this thing to this thing and from this thing to this thing, correct? Yeah. So what I do is I say, well, what does f of that thing even mean? Right? Because this is something I like to use as an example, but it's maybe. So in this case, I've said already that f of x is equal to 1 over x plus 5, correct? Let me ask you a question then. Then what is f of a? So if x is the variable, this just says whatever you have in here, just say it's 1 over that thing plus 5. So in this case, if I put a in there, it's just 1 over a plus 5, right? Or if I put 5 in there, it's just 1 over 5 plus 5, because 5 was the thing that I stick in for x. Or sometimes I say something like f of Joe, right, is just 1 over Joe plus 5. Right, so this thing, it doesn't care what's in there. It just says whatever you stick into the machine, make it 1 over that thing plus 5. So when I said, okay, I have f of 5 plus h, then it says, oh, then it must be 1 over 5 plus h plus 5. Because just whatever is here, I just replace that thing with whatever's here. So I say if a is here, this is an a. If 5 is here, this is a 5. If Joe is here, this is Joe. Make sense? So in this case, what's in here? 5 plus h. So I put in a 5 plus h. In this case, a 5 is here, so I put in a 5. Does that make sense? So I just take whatever the machine tells me to do, and I plug in whatever is the input to the machine. Does that make sense? And then we just keep going. And that's going to be the same on all of these problems. You're going to have to make that first jump of what does that mean? Yeah, good question. Other questions? Yes.
Could you do 51?
51. Okay. 51. Okay, so suppose the speed of a car approaching a stop sign is given by v of t is t minus 5 squared, okay? Where t is measured in seconds and v of t is measured in meters per second. Then it says find v prime of 3. Okay. So we've got v of t is equal to t minus 5 squared. For 0 to 5, t is okay. Find v prime of 3. Okay. So in other words, we're just saying find the derivative of this thing at 3. Right? And it using a v can throw us off, and t's can throw us off a little bit, but what it's really saying is what's v prime of 3? Well, that's going to be the limit as h goes to 0 of v of 3 plus h minus v of 3 over h. Sound good? Okay, so basically the same as before. So now what does that mean? So this is limit h goes to 0. V of 3 plus h. Well, what do I even mean by v? V of t means whatever's in here, I plug in for t here. So I get 3 plus h minus 5 quantity squared minus, I plug in 3 and I get 3 minus 5 quantity squared divided by h. Okay, so now I need to do some algebra. So we get the limit, h goes to 0, of, I've got 3 minus 5 inside the parentheses, which is negative 2. So this is kind of just h minus 2 squared. Over here, I've got minus. 3 minus 5 is just minus 2. So this is just minus 2 squared all over h. Okay, so let's move up here and simplify it a little bit. So moving up here, we get the limit as h goes to 0 of h minus 2 quantity squared would be, I'm going to square this out, it would be h squared minus, let's see, 4h, and then I square this one and I get plus 4, and then I get minus 4 all over h. All right. Then notice I have a 4 and a minus 4, so those cancel. And I'm left with h squared minus 4h over h. But one thing that I see is on top, I could factor out an h. If I did, I could write it as h times h minus 4 over h. And that's perfect because my whole goal here is to be able to cancel out the h on the bottom. So I do, ching, ching, and I get the limit, h goes to 0 of just h minus 4. So now I can plug in the 0 for h. I don't get any division by 0, and I'm left with -4. So that is the answer to what is v prime of 3. V prime of 3. And yeah, for those of you who know a little bit about physics, what are we calculating right now?
Acceleration.
Yeah, acceleration. And so what would this be? What would be the units on this thing? Yeah, is it in meters here?
I believe so.
Let's see. Yeah, meters per second. Yeah, so this is in meters per second squared. And yeah, this is the acceleration of the car, right? And it's interesting because like at time 3, what is the actual, this is the velocity, right? So what is the velocity of the car at time 3? Well, it's 3 minus 5, which is minus 2 squared, or 4, right? So we've got a positive velocity, but we've got a negative acceleration, which just means that we're stepping on the brakes, right? So when you step on the brakes in your car, you don't go backwards, right? So it's okay to have a positive velocity, but a negative acceleration. And that's what it's saying, is that the rate of change of the velocity is negative. So it's becoming less, is basically what it's saying, is that your velocity is going down at that time. Did that answer your question? Okay, perfect. We're almost out of time. Is there a short question I can answer, or maybe one on question I just did? Yes.
Just a short question. So for some of them, they're having us find the derivative of a linear equation. That's just going to be the slope that's there anyway, right?
Yeah, if you're finding the derivative of the
Yeah.
line,
Like they have
it's
prime-
just the slope of the line.
Yeah, it was like f prime of 8x or something. F prime.
Yeah, and what's the derivative of like 8x at a point? 8, yes, that is true. And we'll, even in the next section. So one thing about this is going through this limit of the difference quotient process kind of stinks. And if you've taken any calculus before this, you know that like things get better. It's still good to do it, okay? Some people are like, well, if there's an easier way to take a derivative than this, then why don't we just jump straight to that? And here's the answer to that question, is because then we forget something that's really important, and that is that every derivative is a limit. Okay, and this teaches us that derivatives are limits. And then it's kind of like, but this is annoying. So is there a better way to do it than what we did right here? And the answer is yes, and that's what the next lecture is about. It's like, okay, so now that we understand what a derivative is and how you calculate a derivative, does it get any better than this? Is there an easier way to calculate derivatives? And the answer is yes, there is, and we'll get there very soon. And we'll start to learn what are some tricks to make our life easier so we don't have to go through this process every single time. Okay? All right, have a great weekend. I will see everybody on Monday.